Stemming is a text normalization technique used in NLP to reduce words to their base or root form by removing affixes. It is a simpler and faster technique compared to lemmatization, another text normalization technique. Stemming uses a set of rules or algorithms to remove suffixes and obtain the base form of a word. For example, words like run, running, and runs would all be converted to the root word run after stemming is applied. There is not just one type of stemmer. NLTK provides different stemmers, and here are some of the examples. The first step of stemmer is lowering the case and normalizing the tokens according to predefined rules. Both Porter and Lancaster stemmers normalize "Bunny loves NLP," while the outputs are different. For example, Porter stemmer converts bunny to boonie, while Lancaster stemmer keeps it as it. Porter stemmer only removes s from a loves, while Lancaster only keep a love to represent a loves. So, which one we should use, it depends on your data and your experience to figure out a suitable one for your dataset. Lemmatization is a crucial process in NLP. It involves grouping together different inflected forms of the same word to analyze them as a single item, identified by the word's lemma or dictionary form. Unlike stemming, lemmatization depends on correctly identifying the intended part of speech and meaning of a word in a sentence, as well as within the larger context surrounding that sentence. This makes lemmatization a more accurate and context-dependent process, but it also requires more computational overhead and is slower due to the morphological analysis it conducts on each inflected word. So here are examples of lemmatizations. Just like stemmers, we have different implementations. For example, both NLTK and Spacey also offer their own versions of lemmatizers. You may have already noticed that they produce different outputs. The WordNet lemmatizer from NLTK will not convert is to any other form in our example, while the Spacey lemmatizer will convert is to the be. Both of them also convert leverages and materials to a leverage and a materials, respectively. Stemming and lemmatization are both word normalization techniques used in NLP. Both methods reduce the number of unique words that need to be processed by an algorithm, leading to improved model performance. This technique allows NLP models to learn links between inflected words and their word stems, helping the model understand their usage in similar contexts. They aim to reduce inflected words to a common base root, but they have distinct differences in their approaches and outcomes. Stemming is faster, but it may result in the loss of some semantic meaning, as words are reduced to their base form without considering their context. The algorithms are based on heuristics and may not always produce accurate results. They can sometimes generate word stems that are not real words, leading to potential ambiguity. Lemmatization and stemming are both techniques used for text processing in NLP, but they differ in their approach and outcomes. Stemming is faster but more crude, often leading to unmeaningful base roots. On the other hand, lemmatization is slower but more accurate, considering the context and providing meaningful dictionary words. When deciding whether to use stemming and lemmatization, it is important to consider the specific requirements and objectives of your NLP task.